next reaction of aldehydes and ketone. The second guy is called the condensation reaction. Now, what is the difference between this particular reaction and the one we just completed right now is the reagent that is reacting with them. And condensation simply means two things coming together to lose water. That's basically what it means. Two things come together and water will be eliminated. All right, so the reagent used here as follows. The first one is ammonia. The second one is ammonia derivative, which is the first one we have primary amine. We have hydrazine. We have all right, so these are the three major reagents we are going to be before. Now, if you notice one thing about these reagents, all of them contains nitrogen and at least 2 hydrogen. It contains hydrogen, nitrogen, and at least 2 hydrogen. Now, let's look at the first one. But let's look at this. If I have a reaction with this with ammonia, we have, let's say, CH3 plus. If I want to carry out this reaction, please, I'm going to rewrite this guy. Just look up. This is going to turn out. This will turn out to be. I want to rewrite this so that you see how we're going to form our product. It's more like saying CH3, C, this. I put it this way. It's actually not necessary to have to put it this way, but I just want to use it to explain some. Plus, you have ammonia in this. It's not so. Plus, what I want to, this two thing will come out. What is going to come out of this two? 2H is always coming from the reagent, and the O is always coming from the aldehyde or the ketone. That is why, if you check out all the reagents I get to us, right, all of them has at least 2 hydrogen, at least 2. So the product of this guy becomes CH3, C. Now we have NH, right? Now you have to use a double bond to join this guy, because this guy has lost 2 bonds, 2 hydrogen, which is 2 bonds. This guy has lost oxygen, which was holding how many bonds? 2. This is 1 and 2. So you have to join this with this using the double bond. So this becomes the product of that guy. So we need to understand it before we start talking about how to name them. The name is not really that important as far as you guys are concerned. I'm going to show us how you can name it, right? So basically, take 2 hydrogen from the reagent and take 1 oxygen from either the aldehydes or the what? Ketone, and form water, very, very water. And then join the remaining parts together. Alright, so the next one is reaction with primary amine. We take note that aldehydes or ketones react with primary amine to form what we call imine. All of them is actually imine, but this particular imine is what we call the ski base. They asked them this question sometime ago, last, I think some years back. So reaction of aldehydes, you can just take note of that. Reaction of aldehydes or ketones with primary amines give what we call what? Skip base. Skip base. Take note of that. Now, what is a primary amine? A primary amine have the general formula RNH2, where this R is an alkyl group. So we can have CH3, NH2 as an example of this. So this is methylamine. All right, so let's look at an example. We have CH3, C double bonded to O, CH3 plus CH3 NH2. Class, look up. It's just stop right. Now this is a question. We are asked to actually give the products. I'm going to rewrite this, right? But in exams, you can just give your products. So this is what I'm going to do. I'll bring this CH3 down. You know you see the same thing, right? You see the same thing. I'll put this guy like this. What this is saying is that these two H on the nitrogen, right? The two H on the nitrogen will actually pick this oxygen here and form water. Is it also? So once that happens, we have CH3, this. Now, please look up. I'm now going to turn this. This moves out and takes this and form what?
Water.
Water. Is it also?
Yes.
Now, this is what is going to happen. Or let me just rewrite this so that you can get to understand how we did that. This is H2 and CH3. This is still the same thing like what I had earlier. I just have to turn this. Also. So this 2H picks up this guy and form the water. Is it also? So when you now join them together, the O is out here, leaving us with this double bond. Is it also? Yeah. This 2H is out, leaving us with just what? N. Then that becomes N CH3. That is the product. And this is what we call our words. Skip. The next reaction here is reaction with hydroxylamine. Hydroxylamine is NH2OH. Now, anytime aldehydes and ketone react with hydroxylamine, the product is always oxide. So the product of this reaction, the product of reaction of aldehydes and ketone with hydroxylamine is oxide. Alright, depending on what's reacted, if it was propanone that reacted, the product is going to be propanone oxide. Alright, now once again, we've seen the structure of hydroxylamine. It's also having two hydrogen on the end. So we'll come here, we'll put CH3. This is propanone, preferably to show us how the reaction is going to take place. I prefer also writing this off. So this is NH2. This is hydroxylamine. But just to show us how the reaction is going to take place, instead of saying NH2OH, I can bring this 2H to this guy so that I will have H2NOH. Right? So that this takes this O and form water. This N joins up, it becomes CH3, C double bond, and OH, CH3 plus water. Now this is oxide. Remember I said the product is always oxide, but the oxide depends on the aldehydes of its own inside of it. This is propanone. So the product becomes propanone oxide. Alright. Okay, the next reaction is reaction with hydrazine. Of course, you can see hydrogen has this NH2. Most of the time, you can see it as N2H4. It's also molecular formula for hydrazine, N2H4. Which if you actually split it, you have NH2. Now, class, the product of reaction when hydrazine reacts with aldehydes and ketone is called hydrazole. In the case of hydroxylamine, the product is oxide. So if you use hydrazine to react with either aldehydes or ketone, the product is going to be hydrazole. Alright, so let's look at an example of what we are going to have. We have CH3 plus once again 2H from here, take this O. You have your water. Now once you remove H from here, remove this O. Now this is what we're going to have likely. We have CH3, C, CH3. We have N, NH2. Right? 2 hydrogen has been lost here, 1 oxygen has been lost. So when you put a double bond here, you have this. So this becomes 1, 2, 3, propanone hydrazole. That is the answer to that question. No, you can use anything of your choice. It must not be propanol, you must use any one of your choice, but just make sure that you carry it out accordingly. Okay, what if you want to use ethanol? Let's say CH3, this is ethanol, plus now this forms water. So half plus water. Now this is now ethanol hydrazole. So that is that for this particular reaction. It's